and everything is like extra slow. See what happened to NetBeans here. Exactly. It's just like children. I mean, you can. Should is a different.
I've been told you're not supposed to.
You're not supposed to kick printers either.
Well,
All right. I think we're back. Let's see if the projector cooperates now. Nothing. Black screen. That's awesome. Why? Laptop is nothing. PC is something. HDMI cord. Nothing. Let's try pressing all the buttons here. I got more buttons here. 1 second. All right, that's the computer. 3 dot cam. 2 nothing. 1 it's nothing. 6 should have been laptop. I did this last week and then it just started working again. Oh my goodness. Really nothing? Yep. Definitely knows I have more than one display. Oh, maybe it doesn't. Try this one real quick. Still nothing? All right, that's 2 computers it fails on. I'm gonna blame the hardware, not my laptop.
use it in the portfolio and the other things like the dot cam.
Maybe. The way it's all hooked up is usually kind of convoluted. This one only has 1 output. Still nothing? Oh dear. Yeah, it's all, I don't know, it all plugs into the back of this stuff. You can also try turning the projectors off and on again. Or you could go to the Twitch page and watch it when I'm screen sharing. I mean, maybe while we wait for this to turn on and off, or... Oh, wait, I'm blinking. You thinking about it? Still nothing. One of those days, friends. All right, let me try projectors off. I'll do turn projectors on and then I'll connect the HDMI. Maybe that'll behave better. Just gotta wait a second while it turns off all the way. Yeah, a couple more seconds. Did that other projector turn on? That one? No. Control panel lies to me. There it goes. There's on. We got the PC. Let's try HDMI again. Plug in. It blinked. Saw it connected. Nothing. Holy crap. Alright, I can do Twitch on this computer. That can connect projectors. I don't know if that's any better. I think it can full screen mode. Oh no, my power cord. I know, if it happens again, we just have to quit. It's 2021. I can't make a laptop work. It's not sad at all.
There's someone working in a computer industry doing something. I don't know. I just know they worked on computers, but he didn't know the actual physical aspects of the computer because the boss said to get rid of the ugly boxes underneath the desks, and they did.
Wait, computer desktops, the towers are not ugly. Like they look fancy, don't they? All right.
All I know is that he basically got sued by the company because they got taken to the dump, and it was company information on them.
Nice.
Yep.
Yeah, there's definitely gonna be a little bit of lag between what I do here and what shows up on the screen because we're watching Twitch on the other computer. If it does connect, we're gonna make do the best we can. I'm sorry. Really sorry. We're almost through it. All right. All right. We're gonna try it. If it's terrible, let me know and we'll just quit and feel bad about ourselves. But I think we're getting there. All right. A couple other really handy shortcuts. Oh, we didn't finish the ones place thing. That's right. It did save, thankfully. So I'm going to go to GitHub and commit and push because once the cloud has my code, I'm going to feel better about it just in case something really happens to my laptop. And it's a good habit. Commits are free. You commit early and often, which I should set a better example of, so the cloud has your code. So here's some chapter 3 stuffs. Oh, that's the wrong repository. 1500. There we go. Yeah. Chapter 3 stuff. Okay, that's not even too much lag, right? Just a minute. What was that 5 seconds, maybe? Oh, that's more like 10 seconds. Jeez. All right, give it the commit message, push. All right, we'll come back to NetBeans. All right, so again, more shortcuts because we love doing things that are easy. So what I can do now, I have my ones place, I have my tens place. Right? I'm going to say, okay, well, this one's not even really a shortcut. Let me have a new result. We'll say the ones place plus the tens place, right? And we're going to say your ones place plus tens place equals, and if we do the result, nope, not a comma, a plus, sorry. You know what they're going to equal every time? You multiply a number by 9, add up the tens place and the ones place, it's going to equal 9. This was probably like way back in like 5th grade math class that you did stuff like this, but my kids still think it's a cool trick. And it's compiling. It's thinking. Goodness. I'm just going to close. Favorite color. Sure. Enter number 1 to 9. What number should we do? 1 to 9. 2. Number times 9 has a 1 in the, oh, I'm missing a space here. Space in the tens place. And an 8 in the ones place. Your ones place plus tens place equals 9. Video buffering. Use low latency to disable low latency mode. Don't we want low latency mode? I'm confused now. All right, so any number times 9, right, when you add up the ones place and the tens place, for the single digit numbers, the other ones should work as well, but you have to like add up the hundreds place and the tens place and the ones place. It's kind of fun. Any magic number. When you do 3-digit numbers, or like 2-digit numbers multiplied by 9, you can get 3-digit results. You take those digits and you do it again and add up those digits. And those digits will add up to 9. Okay, you guys aren't into math. That's all right. It's a fun trick. Anyway, so shortcuts, right? So if we say, hey, I want to have an int for count equals 0, and I'm going to ask you, we did the guess a number thing before, right? When we were guessing a number to see if it was right, and the magic number was 42. Okay, all right, cool, that rings some bells. So if we do a count and I want to increase the count, right? So we'll say, hey, that's a number 1 to 100. Oops, that one there. Every time you guess, right, I can have an int, guess is integer.parseInt of the keyboard.next line. I can take my count, maybe we should call this maybe count of guesses. I'm going to take that plus plus. So plus plus is a shortcut operator, count of guesses, to say add 1. So it's just adding 1 to a number is common enough that we have a shortcut for it. So plus plus, we'll add 1 to it. Minus minus, we'll take 1 away. So you can count up or you can count down 1 at a time. It's the same thing as doing like count of guesses equals count of guesses plus 1, or the same thing as count of guesses plus equals 1. So they're all equivalent, right? Same as above. Right? Any way you want to write it here, perfectly fine. Whatever you prefer, your preference. Okay, so that's just a shortcut operator, right? If something seems like it's taking a long time to type out, there's probably a shortcut for it. Because programmers are lazy. Okay, cool. So there's some considered unary operators, right? It operates on a single value. Like, so if the count of guesses is being operated on, that's a unary, only needs 1 operand. Right? When you like add 2 things together, you have 2 operands, the left and the right. So they're not unary operations, just if you want technical terms. The other weird thing you can do, so this will use the value and then add 1 to it. So you can do this inside of prints here, which is really funny, or other things. So I can say, hey, print the count of guesses. This is a postfix increment. That looks right. So it's going to give me the value, and then it's going to add 1 to it. So when it starts off at 0, it's going to print out 0 and then add 1. Okay. You can also do a prefix increment, which will add 1 to the value and then use it. So I could say plus count of guesses. Okay. Both of these will work, but it's going to change the value either before I print it or after I print it. So if our color's blue, enter number 1 and 9, we'll do 9. Sure, guess a number, 42. Right, so the value was 0 of count of guesses. Then we added 1 to it. Then the value was 1. We added 1 to it, became 2, and then we used the value. So prefix adds before using the value, and postfix adds after using the value. So again, not all that important one way or the other. Just know, like, if you're expecting it to have a value and it changes after you used it, weird things can happen. Someone told me once that this is faster, and I have no idea behind the scenes if it actually is or not, and I haven't bothered to Google it because I don't really care that much. For negative, you just use the minus sign. Like if you want to flip the value, so like count of guesses equals negative count of guesses. Right? You can make it negative if you want. Sure. No big deal. That one's not as interesting. Negative. Right, and then combined assignment operators. We did this plus equals 1. Where did that one go? Right here, right? Plus equals 1, that's our combined assignment operator. We do plus equals, minus equals, times equals, divided by equals. So any of these arithmetic operators will operate on this value, do this thing, and then assign it back. I feel like we talked about those already. Is that new? Okay. Yeah, sure. Yeah, order of operations we talked about. Okay, I feel like this is out of order. It's so weird. Now, if you really want, you can do weird things. So with all of the primitive types, they hold specific values, but you can say, I want to be treated as a different type. So what we did, like when we convert here, this isn't considered casting. So when we talk about casting, we're saying just treat me as another type. This parsing here is saying, please read it and convert it for me. So the parsing here is different than the casting. Screen's behind. It'll catch up in a second. There's the parse. So if I want to, I can say, hey, I want an integer value. We'll say letter E equals, and I can give it the character E. So implicitly, it's saying, oh, I know a character is a numeric value. You can store a numeric value as an integer. The integer can hold more than this character size, but that's fine. So going from a smaller size to a larger size is always fine. So going from smaller size to larger always works. But you can't go from a larger size to a smaller size. So if I wanted to say, hey, here's a byte, I don't know, if we did like a float, some another number equals 4.2, remember now it's going to yell at me because implicitly 4.2 is considered a double. And the error here is incompatible types, possible lossy conversion from double to float. And it's not smart enough to know that this particular double doesn't have 7 decimal places or less, and that it actually fits as a float. So it doesn't know that. It's not smart enough. It's just saying, hey, you're trying to fit a big thing in a smaller thing. They probably won't fit. So the warning there is lossy conversion. You could lose some information when you try and convert. It's no good. So to cast it, to do the casting piece, we in parentheses, we say, hey, I want this as a float. So it's actually taking a double and then converting it to a float, rather than saying, here's 4.2f for a floating point value. So this is doing a conversion with, it's called casting. It's saying treat it as this particular type, and then the warning goes away. So we can do the same thing. So if I had a long, some long number, and I don't actually need it to be super long, right? As long as it will fit as an integer, fine, let's do like a million L for long. That's fine as a long. And then int, I want let's say a casted long equals the some long number. I'm going to get the same error. Possible lossy conversion from long to int. Because as far as it can tell, I might lose values. It doesn't actually check to see, oh, this one actually fits. Oh, that's weird. 1 million. Right, so if I want to treat it as an int, I can just say, hey, cast as an int. I put an int in parentheses in front of it, and that tells Java, yes, please just turn it into an int, cast it as an int. It's not saying try to read it, try to convert it like the integer.parseInt. This is just saying, just jam it in there. Now, the weird thing that happens is if it's actually bigger than the integer value. Right, so if I take, what is it? We can fit 1 billion, but we can't fit 10 billion. Right, so 10 billion fits as a long. Oh, that was an L, not a 1. I can't. My goodness, I thought that was a 1. It looks exactly like a 1, right? I guess the 1 is slightly pointed down and the L is straight. That's a terrible font. Really bad font choice. Sorry. So I can take a long that is larger than an integer and tell Java, hey, treat it as an int, save it here. I'm not going to get my 10 billion number here, right? I'm only going to get the leftover bit, which is probably not going to be very helpful. But Java lets you do it. So casting is dangerous sometimes because you could lose that precision if you're not careful. Now, like with 4.2, I know I don't have more than 7 decimal places. Fine. Not a problem here. So this will cause a loss of information, value, or I don't know, loss of value. I don't know the right word, whatever makes sense there. Like it was 10 billion. I can't fit 10 billion in an integer, so I only get whatever's left over, whatever does fit. And hey, you know what? We can look here. Let's do this just for fun. No, I might not get it right. That's okay. I was going to try and do all the bits for 10 billion, but there's also the bit in there for positive and negative. I can never remember which side it's on. So it'll run. It's not even going to crash. Oh, I should print it, right? We'll print the casted long. Let me restart this. So I'm going to stop and restart. All right, favorite color, blue, number 9, sure, 42. Here we go. So what's left over when you cast 10 billion as an integer is 1,410,065,408. I've got no idea. Behind the scenes somewhere, this is something neat is happening. I don't know where it's losing it. All right, we're taking a big number that doesn't fit, trying to store it in the smaller number, and we're losing that precision, losing some of that value. But Java lets you do it, so just be careful. Right? So sometimes casting is great. Yes, please do it because I know it fits. But if you're dealing with user input, who knows what they're going to give us, right? Like if they give me 10 billion and I then treat it as an integer, I'm going to have a problem. Now the nice thing is that integer parseInt will just crash on you. So let me run this again real quick. Right, when I go to enter a number and I use integer.parseInt, it will crash. The casting is not going to crash anything. But when I say enter a number, so if I enter 10 billion, so there's 10,000 million billion, it crashes. And I get this big old red. This is called a stack trace. So it says, hey, and you kind of read them from the bottom up. So at chapter3.chapter3.main. So it's saying my main method in the chapter 3 class in the chapter 3 package. So package, class, method. Don't worry too much about it now, but at line 56 is where it happens. So if you click it, it'll actually take you right to line 56. It's a little link. It's handy. Then the rest of the error is inside of Java language integer parseInt. Something went wrong with parseInt. Well, the problem was a number format exception. And then the actual message here, input string 10 billion, just crashed with a number format exception. So the parsing here where it's trying to convert will crash on you. The casting will not. Okay, so just a heads up there. And we probably did want it to crash because I had no way of actually storing 10 billion. And if they really wanted me to do their operation with 10 billion, it's not going to give them the right result. And that's probably a bad thing. Right? I mean, we're probably not doing anything interesting like calculating distances for lunar missions or anything. But you know, if you imagine you were doing something important and you lost some precision, bad stuff would happen. Okay. It's also why we should all just use the metric system. It's just so much easier. All right. Yeah, there was one big crash that happened because someone didn't convert between metric and US systems with some space thing. I forget what it was. It made the news and made us all look stupid. Like, get with it, the United States. I don't know. One of these days, maybe we'll convert. Yep. All right, so some other cool things we can do. Java has these things called wrapper classes. So like integer.parseInt. Integer is technically a class here, so we can do cool integer things with integer dot. It gives access to all the fun things Java knows how to do with integer. Integer dot, and you get cool things like toString. If you give it an integer value, it will turn it into a string. You know, all the printing we've done so far, you just give it a value, and that happens implicitly. But what that can save you from is like if you take that number plus 10, right? It's going to do the arithmetic here, not print this as a string plus the string 10. So just if you really want that to happen, right, we could use parentheses for order of operation, or we could say, hey, I want integer toString of the casted long plus the value 10, and then it's going to know, or you can even do integer toString again of the value 10 if you wanted. You can get real silly. So it'll convert both of them to strings, and then the plus sign will append the strings together. Right? So if you want to be very explicit and make sure you're not accidentally adding numerics together inside of your outputs, we can do it this way. Just an option. So that's fun. Double has the same things, right? Double, there's parse double, or there's toString. There's other fun things, like you can turn into a hexadecimal string if you want to. Sure, that's all sorts of fun stuff. But if you want, you can use those wrapper classes to create values. I don't recommend doing it. So instead of the type of int, which is a primitive type, you can say, hey, I want the integer type here. And this is the integer object, the integer class. We'll talk more about that, what that means later. But I can say, hey, I want integer, full class integer equals a new integer, and I can give it a value inside of the parentheses. And it's telling you, hey, it's silly, don't bother doing this. Right? It's been deprecated, don't even bother with it. It's still supported, but Java's like, why bother? So now I have this full class integer. Oh, I can't even spell integer. Integer. That looks better. Now the one benefit, right? I can take that and I can say dot, and I get my toString. If you really wanted, right? We can then turn that into a string, that instance. What I can't do is take like the casted long and say dot toString. So sure, it's ever so slightly different. You're allowed to use that toString method on this one because it's an instance of a class, which doesn't make a lot of sense. We'll talk more about that later. But if you see this, it's not really wrong. Just no, like it works. Okay, that's all. We're parsing. All right, other cool things. Here we go. So the math class in Java. If you type capital M math and hit dot, we have access to lots of cool things math related. Abs, like absolute value. Again, I don't know why they didn't use better words here. Like they left off a bunch of letters and it's confusing for people, but sure. Absolute value. Arc cosine. Arc sine. arctangent. Ceiling is going to be really helpful for you. So ceiling will give you the smallest, closest to negative infinity double value that is greater than or equal to the, oh my goodness, why is that funny there? Can I make that bigger? Equal to the argument and is equal to a mathematical integer. So this is actually a comment in the Java API that got turned into this documentation. This is a pretty cool comment, right? It tells you what it's doing. It's very helpful. So when you're writing APIs for other people to use code, comments can be nice and helpful. So smallest, closest to negative infinity double value that's greater than or equal to the argument is equal to a mathematical integer. That's the next whole number. Right? Is that big word sandwich? Right? It's rounding up to the next whole number. If you're already at 4.0, it's going to stay at 4.0 because that is a mathematical integer. Greater than or equal to. So if you're equal to a mathematical integer, it stays. If you're not, it's going to round up to the next integer, but is going to stay as a double. So this will round up your number of pizzas that you need. Math.ceil. Right? So you just type math, and you can say ceil. You can do all sorts of cool things. Cosine. Oh, goodness. Hyperbolic cosine. I think that's cosine h. Floor is the opposite of ceil. It will round down to the nearest whole number. Don't round down your number of pizzas. If there's not enough pizza, people are going to be upset at your party. Although there's a funny thing, like a good picture of America. If you show up at a pizza party and there's not enough pizza, some people will take one slice because there's not enough, and other people will take 3 because they know the pizza's going to run out. I feel like that's kind of true. But, all right, anyway, we're here to talk about programming, not people. Yeah, all sorts of math things. Min will give you the minimum value of 2 different numbers. Sure. And you see that like these look repeated here. You can give it doubles, you can give it floats, you can give it integers, you can give it longs. So you can give the different types here, and it will figure out the mins for them. Right. Random is fun. You can get random values. So this one actually we frown upon using. There's a better way to get random values we'll talk about later. But essentially it works. Don't worry too much about it. Right. So ceil, right, will round up. Let's do ceil. So 4.2 rounded up, and so I can stick all of this in a print line. So math.ceil rounds up to the nearest whole number. Right? So that's a nice helpful one for you. So 4.2 rounded up will give us 5. There's a pow method for power, like take a number to the power of to multiply. So math.pow will do that for you. You can check all these out in the book here. Square roots, if you want to do square roots. Random is fine. Again, I prefer to use a different way of using random, but that's okay. And then number formatting. There's a fun way you can format numbers so that when you print them out, they turn out really pretty. So like, if you take pi and just print it out, you're going to get a bunch of decimal places. So math.pi is actually a value here, and it's uppercase, right? That means it's a constant value. Right? Remember, we can define our own constants or finals. So we can print out pi, and we're going to get a bunch of decimal places. We should get 16, I think, because that's as many as a double can hold. Let's double check. We want to count decimal places, right? That sounds exciting. Color, number. There we go. Oh, it's not quite. Is that 16? 2, 4, 6, 8, 10, 12, 14. Oh, 15 decimal places. We got 15 decimal places of pi. If you don't want all 15, right, we have to format the output here. So to format it, it's this really ugly way of doing it, but it's okay. You use a number format. So I can say, hey, I want a number format here. So that's the type of value I want to use. So number format, we'll call this my formatter, equals, and then I'm going to give it a particular number format. So the number format class here, format dot. All right, it doesn't know what it is. We need to import it first. So we'll add our import java.text.numberFormat. Now I can do number format dot number format. Come on. Give me all my formatters.
The last format spelled wrong.
Thank you. That would explain why I didn't get anything here when I hit dot. Dot. All right, there's a whole bunch of built-in ones. So if you want percentage, sure, I can give you percentages. It'll even do it in given locales. Other countries, I don't remember which ones, use a comma as the decimal place and decimals as commas for number separators, groupings. I get really confused, but like if you see a lot of periods and then a comma, 00 or something, they're probably using a different format. So it knows how to do a lot of those. You can format for currency. You can get a currency formatter. Like it'll automatically add the right currency formatting for you here. Let's do, that's the default one. That one's not very interesting. It's what's a fun one? Let's do it as a currency. Why not? And then a semicolon. Then to use it, I'm going to say, here's my string for, this is pi as a percentage. Sure. Is my formatter dot format given math.pi. Or any value that you want, right? Any double that you have, right? If you've done some arithmetic and said, hey, here's your percentage score, sure, we can format it as a percentage. Then I can print that out. My pi as a percentage. Or you could just take this whole chunk here, the format, and stick it right in your print if you want as well, right? You don't have to save it as a string and then print it. You could just print all of that right off the bat. Just say, hey, format this thing, please. So either way is fine. If you want to save it as a variable, you can save it as a string, or you can just print it right out, depending on what you want to do with it. All right, blue, 1, 1. Oh, this was currency, not as a percentage. Oh my goodness. $3.14 for pi. Pi as a currency. All right, so let me show you something. If you want to change the variable name for something, you can just click on it and change it, but then you have to change it everywhere else you used it. And right, we're good lazy programmers. We don't want to have to change it multiple places, so let the tool do the work for you. If you right-click on it and go to Refactor Rename, it will say, okay, what do you want to call it instead? You pick a new name. So this is pi as a currency value, and you click on Refactor. It's going to find everywhere you're using it and change it for you. Kind of like a find and replace, but it does it for you. And it will refactor it everywhere in your entire project. It's really smart. When we get into using classes, we'll have more than one just Java file, and it's really nice to change it in all of your files rather than just one place. So Refactor Rename is your friend. All right, so pi as a currency value, sure. Now you see we get the $sign, we get the decimals, it gets rounded off to the correct location. So the number formatter is really helpful. You can use it for a couple of kinds of formatting. Just go look it up. It's not worth memorizing, right? Just if you want to use it, go look it up. The book has all the examples. You can Google examples of Java number formatter. No big deal. So they take you through, hey, let's calculate some sales tax and print it all out and make it look nice and pretty. All right. Yeah, if you want really big numbers of decimal places, there's a whole class for big decimal you can use. It's not all that interesting. But if you really want lots of decimal places, go for it. Yeah, it takes us through that. Awesome, and that is it for Chapter 3. We survived it, folks. It is a lot, right? So the idea is we go over the highlights, take some time to practice it, play with it. We're going to use this stuff later on in the next project, right? Like, so that the next project gets assigned, we'll use the stuff from chapters 3 and 4, but you don't get to forget anything from chapter 1 and 2, right? Everything's going to build on itself. So we're not getting rid of our if statements. We're not getting rid of the while loops. Right? We're going to use those things as we do more and more with our primitive values and on and on and on. Right? So let me take a look at our schedule again real quick. And I'll post the chapter 3 quiz tonight in just a minute. So again, we'll do a quiz every week. It'll be due the next week by 11:59 p.m. in case you forget to take it, and I remind you in class, and then you go take it real quick. Sure. Ideally, they're free points, and you go find where it is in the text. Don't memorize anything. It's open book, open notes. Go find the reference. Go look it up. You'll be in good shape. If it marked you wrong on any of the fill in the blank stuff, let me know. I'm happy to fix those for you. Yeah, so Bell TTVS, you can use the math.seal for the project. Right, so project 1, our little pizza calculator, right? We'll use math.seal to round up. The other way you can do it if you want, right? We could check and say, hey, I have some value here. So this is my, double number of pizzas is going to be some arithmetic, right? If I said like 42 divided by 7, sure. Whatever happened to be, right? If these are integers, right, we're going to lose that precision. So make sure one of your values is not an integer when you do your division, right? So the other thing you can check, we can say, hey, this is an int for remainder. And we can do, hey, if I do modulus 7, if my remainder does not equal 0, then I have some left over. I can go add 1 to my pizza count. Right? Add another pizza. Right? So I could do integer division, let it truncate the decimal, lose my decimal for my number of pizzas, and then if I have a remainder, add 1. Or you can use math.seal. Right? Math.seal is probably less typing than checking your remainder if it's not 0. Because if you can evenly divide out, you're not going to have a 7-slice pizza, but that's fine. Right? Your number of slices that you need divided by the number of slices in the size of pizza. Right? Does using modulus make sense there? And we could check this way, or just use math.seal and it will round up for you. All right, so we got the project coming up. That's next week, 6 p.m. You need to make sure you've committed it to the GitHub repository and then come back to Desire to Learn and turn it in. Okay? Some people think as soon as it's in GitHub, they're done. Sure, yes, the code is out there, but until you turn it into D2L, I'm assuming you didn't give it to me. Right? And I haven't actually figured out your names and linked them all up to your GitHub repositories. None of that's magic. So you have to turn it in so the flags for grading, and then I get the link for it, and I know who's who with your actual name and your GitHub name. So it should work out well. If you haven't done Project Zero yet, I think everybody turned them in. We only have 24, I think. So they're all in. I'm sorry, I'll get those scored later tonight. I think we finished that up before everybody left last week. No, 2 weeks ago. Yeah, 2 weeks ago. My goodness. Last week didn't happen. That was the power outage. Yeah, so next week, 6 p.m., we'll go over this one first, and then we'll get into Chapter 4. Right, and we'll kind of keep that same flow. So a new project every 2 weeks. We'll be doing the start of class. I'll go over the answers, and we'll go from there. Right, I think that's it then. So I'll post that quiz. We should be in pretty good shape. So we got the rest of the night to practice some of this stuff. Get working on Project 1 if you haven't started it yet. Got some time. Hopefully before you walk out of here, you can be done with it. And then next week, we'll get more into control statements and talk about the next project. Okay? Cool. Sorry, I don't know why the projector's not working. I'll talk with our IT folks. Class tomorrow morning. That'll be fun. At least they're on campus, though. They're not on campus in the evenings, which is a little bit unfortunate. Okay. Any other thoughts, questions, concerns? We good for now? Cool. All right, let me turn this off. Thanks for hanging out online. Sorry for all the crashes. I'll get the videos posted out to YouTube. It'll probably be like 3 different links because it resets the session every time. But I'll put them out there. Take care.